Hello everybody, welcome to the class. This course is about application of new materials in aerospace and navigation. I'm from Zhejiang University of Science and Technology. Here, we will give a lecture about the fourth topic, applications of new materials in aerospace and navigation. The first topic is aerospace material. The aerospace materials refer to all kinds of materials used in aircraft and its power plant, accessories and instruments, which is one of the decisive factors in the development of aerospace engineering technology. And aerospace materials science is also a pioneering branch of materials science. In order to meet the technical requirements, aerospace materials should have high specific strength and stiffness, excellent high and low temperature resistance, aging resistance, and excellent corrosion resistance, and adaptability to space environment. All kinds of materials used in aircraft and its power plant, accessories and instruments are one of the decisive factors in the development of aerospace engineering technology. The design of aircraft puts forward new problems to material science and promotes the development of aeronautic and astronautic material science. The emergence of various new materials also provides new possibility for the design of aircraft, which greatly promotes the development of aerospace technology. So the development of aerospace materials depends on the following three facts. First one, the new discovery of the theory of material science. Second, progress of material processing technology. The third one is the process of material performance testing and non-destructive testing technology. So let's see in detail. First one, the new discovery of the theory of material science. Why? Let's see an example. The theory of aging strengthening of aluminum alloy leads to the development of durable aluminum alloys. However, the oriented arrangement theory of rigid molecular chains of polymer materials leads to the development of aromatic organic fibers with high strength and high modulus. Second, progress of material processing technology. For example, the ancient casting and forging technology has developed into directional solidification technology and precision forging technology, so that high-performance plate materials have been put into practical application. With the development of the design and the technology of fiber-reinforced composite laminate, it has the best performance in different strength direction which makes the composite designable and open up a broad prospect for its application. The achievements of new process technologies, such as hot isostatic processing technology and ultra-fine powder manufacturing technology, have created a generation of new aerospace materials and products with new properties, such as hot isostatic pressing powder metallurgy, turbine sticks, high-efficiency ceramic products. The third one, the progress of material performance testing and non-destructive testing technology. Modern electronic optical instruments can observe the molecular structure of materials without destructive testing device for mechanical properties of materials have been able to simulate the broad spectrum of aircraft, and non-destructive testing technology have also made rapid progress. So, material performance testing and non-destructive testing technology is providing more and more sophisticated information for the design of the aircraft to provide closer to the actual conditions of the use of material performance data for the production of products to ensure the quality of detection means. Only when a new type of aerospace material has been developed to a mature state in these three aspects can be applied in an aircraft. Therefore, all countries in the world give priority to the development of aerospace materials. The basic requirements of high specific strength and stiffness for aircraft materials are light material, have high strength and good stiffness. So, if the material has this characteristic, it can reduce the structural weight of the vehicle. With reducing the weight of the vehicle and the carrying capacity is increasing, as well as the flight distance or the flight range. Also, the maneuverability is also improving, and the consumption of fuel or the propellant reducing. Specific strength and specific stiffness are important parameters to measure the mechanical properties of aerospace material. And this is the definition of the specific strength and specific stiffness. Is the ratio of the, for example, is a specific strength is the ratio of tensile strength to the density of materials. And in addition to the static loss, the aircraft is also subject to alternating loss due to takeoff and landing. Engine vibration, high speed rotation of the rotating parts, maneuvering flights, test and artifacts, so the vertical performance of materials has also received great attention. Then we can see a video. The video is Boeing assembles 787 Dreamliner for Indian Airlines. Okay, that's all. From the video, what kind of materials do you notice in the aircraft? And with the question, we learn the next page. Usually, there are 4 types of new aerospace materials. The most important one is composite, and another is aluminum alloy. Also, aluminum lithium alloy and titanium alloy. This is typical aerospace materials. They all used as structural parts. Okay, we can see the first one, composite. Composite materials in Boeing 787 from the video has been developed to make the main load-bearing structures such as wing, fuselage. All this constructed by laying composite wires and taps. From the perspective of the consumption and development trend of foreign civil aircraft, conforming materials, composite materials have become the main structural materials at present, and the consumption has been greatly increased. The consumption of composite materials in Boeing 787 is as high as 50%. A large number of applications of composite materials have greatly improved the performance of aircraft. Materials are the foundation of the aviation manufacturing industry, which is especially reflected in composite materials. To ensure the safety, economy, comfort, and environmental protection performance requires of the large passage aircraft. One of the important means is to use a large number of advanced composite materials. We will introduce the application of composite materials in aviation field. Composite material is one kind of solid material which is composed of 2 or more substances with different physical and chemical properties. And the performance of the composite material, has been greatly improved. Composite material is composed of 3 parts. 1 is matrix, 2 is reinforced material, and the third one is interface. This picture is the schematic diagram of composite structures. The forms of reinforced material include fiber, particle, whisker, and so on. You can from the structure. In A and B, they are long fiber, and in C, it's particles or short fibers or whisker. Commonly used matrix contains metal matrix, ceramic matrix, resin matrix, and so on. Fiber reinforced resin matrix is used commonly and have a wide application in aerospace craft. So, what role does fiber play? The fiber It plays the role of strengthening and tightening and bearing stress. The body is continuous and transfers force to the fiber through the interface. The interface is playing a regulatory role. At present, fiber-reinforced resin matrix composites are widely used, in which high modulus and high-strength reinforced fiber is the key to obtain high-performance fiber-reinforced composite. That means the key material is the fiber. And the commonly used fibers contains carbon fiber, glass fiber, aramid fiber, and boron fiber. All of this, the carbon fiber is dominant. For glass fiber, it's too heavy. But it's ideal for radium permeable radiums and steels applications. And for aramid fibers, it has low tensile modulus of elasticity, primarily used in bulletproof vests. And for boron fibers, it's much more expensive. And note it has not yet been incorporated into fuselage structures. High strength is one of the goals of the carbon fiber. The biggest supply of PAN-based carbon fiber in the world is Toray. Since 1971, the company produced carbon fiber from tensile 300 to tensile 1000. Another aspect. Light coal is another goal of carbon fiber development. Improve production efficiency and lowers cost. For example, the large tow carbon fiber. Recently, Shanghai Petrochemical in China successfully developed China's first 10,000 tons of 48K ton carbon fiber, becoming the fourth enterprise in the world to master this technology. You can see the picture is a light carbon fiber. Due to its excellent characteristics, especially in lightweight, carbon fiber composites have excellent applications in military, automotive, aerospace, medical, and other fields. Reduced cost can promote its large-scale application. Application and development of composite materials in aircraft. It can be divided in 3 stages. First is non-load bearing components use the composite. Secondly, load bearing components use the composite materials. And the third is primary load bearing component use the composite material. For example, especially for the third stage. The third stage application tends of composite materials in aviation fields. Diversification and conversion from military to civil. Aviation can be used in helicopter, unmanned aerial vehicles, and so on. And in space, it can be used rockets, satellites, spacecraft, and so on. Also used in other areas. For the first generation and the second generation composites used in the aircraft, the typical aircraft is DC-10 and A320. In the first generation, the composite material just used as rubber, fairings, arrows, and spoiler. And in A320, the composites have poor toughness. Yes, this is the defects. And in third generation, the composite improved. The typical production is A380 or B787. Usage ratio from 20% to 50%, and also used as primary load-bearing components. Other used areas such as NASA Helios solar-powered aircraft and Explorer aircraft, and the next generation Agent 10 composite material. It can be developed. Application of composite materials in aviation in China. The research of composite materials in China has nearly about 40 years. Also made considerable achievements, and process also reached a certain scale and level. The composites are mainly used in military aircraft. The manufacturing cost of the carbon fiber for composite is very high. So, because of this reason, it limited the application in aircraft. And in military aircraft, for example, in L-15, used as tail fin, and the Flight 20, the composite material usage ratio reached 20%. And in helicopter 9 and helicopter 10, the composite usage ratio reaches 35%. The application area of in C919 composite is reached 25%. It is developed from the secondary structure to the primary bearing structure, such as the wing, the tail product frame, and the tail section of the fuselage. Sorry. In the field of aerospace, there is a saying that a generation of aircraft, a generation of materials. The application of new materials is one of the most important driving force for the development and progress of aviation technology. Another example, used material in China. In May 2002, China's first developed the Kunlun turbojet engine, which has completely independent intellectual property rights and advanced technology, passed the national financialization appraisal, making that China has become the fifth country in the world that can independently develop aero engine. Besides the above composite material, another kind of material, ceramic composite. In October 2003, China's first manned spacecraft, Shenzhou 5, was successfully launched. Tianma New Materials company produced electronic ceramic substrate with aluminum, successfully applied to the transmitter chip, and China's first astronaut Yang Wei flew into space together as an important part. The second part is new materials used in navigation materials. Navigation. Compared with traditional metal structural materials, composite materials have high strength and to mass ratio, and use of composite materials to build house and structures has light weight, better performance in fuel consumption and speed improvement because so light. At the same time, composite materials also have advantages of corrosion resistance, non-magnetic, and good plastic. Therefore, since the advent, composite material has been playing an important role in the shipbuilding industry. The focus of attention of major shipbuilding countries also give a focus on the composite material. Based on the polymer matrix composite, according to the structure, they can divide it into two types of one is laminates, that is fiber-reinforced composite, just like a layer. And if you want to a thicker board, then you can buy layer by layer to get. And the sandwich structure composite. This structure can be designed as a big manufacturing country of composite ships in Asia. Japan began to build fiber-reinforced plastic ships as early as 1953, and in 1970s, fiber-reinforced plastic composite. That means this kind of composite, the matrix is plastic. This kind of material widely used in Japanese fishing boats, just like this picture. Besides the fiber-reinforced plastic, the carbon fiber is an ideal material used in the field of ships because it can reduce the vibration of the hull, maintain a good wireless communication environment between ships, and so on. At present, the application scope and scale of marine composite materials in China are still small. When ship structures are subjected to impact, vibration, clearing, and fire, composite materials are easy to fill in. Yes, that's the defect for the shortcoming for the composite material. In fact, composite material have great advantages in ship applications, and accelerating the design and development of composite materials is to solve the main problems that hinder its application. The development directions of marine composite materials in the future is the improvement of design technology. So, because the composites have obvious properties, that the property can be designed. So, here said the improvement of design technology. Different structure of composite have or show different properties. Yet besides composite material, the main metals used in civil large aircraft also include aluminum alloy, titanium alloy, high-strength steel, and so on, as well as in navigation area. For example, in August 2010, China's first operational deep-sea manned submersible Jiaolong, independently designed and independently integrated, that means produced, successfully completed its 3,000-meter class sea trial, in which is designed a maximum divide depth of 7,000 meters below the sea level, which is the deepest operational manned submersible in the world. You can see from the picture. In the submersible, it contains not only composite material, but also we can see the metal parts. Yeah, the metal means different kinds of alloy. Okay, even the not only materials, composite materials in aerospace, but also in navigation area. The materials used have shown a great development with the development of technology. And the properties show a development. For example, more and more higher performance and multifunction. Composite is a trend. Intelligent, also to low cost and high environmental compatibility. This is a trend. And the materials will be developed all the time. So the new materials, advanced composite materials will appear. That's all for today. Thank you.